In this video, I'm going to go over the covariance, correlation, and the least squares line, in which cover page 161 to 166 in your book. First of all, let us have this simple example about cells volume data. As you can see, in this data, we have the sales regions. We have 10 different regions. We have the advertising expenditure, which is the value of X for those specific regions. And we have the sales volume in each specific region. The units represented here are interpreted like the following. The 5 mean 50,000. So every number is the actual value is divided by 10,000, just to make it easy to comprehend. The same with the sales volume. When we see 110, it means 1,100,000. Okay. We went ahead and we plotted a scatter plot, as we did in previous chapters, to understand the relationship between the X and the Y. And as you can see, there is some type of trend. If I have an imaginary line that cross those points, so you can see there is some type of relationship. And that's the purpose of this video. We're going to interpret this relationship and understand the meaning behind it and how we can use it in business data analytics to predict future values. So the idea is we want to discover the relationship between X and Y, and that's simple. To be able to do this, you start by defining the covariance, and from the name you can tell this is a relationship between one variable and other variables. So the covariance between X and Y. And the formula is given to you. Since we have a sample, we don't have the whole population. So as usual, when you are dealing with samples, the covariance becomes the sample covariance. And to calculate it, you have to first find the mean of the X, find the mean of the Y. Then for each point we have in our data, we're going to subtract the value from the mean. So the 5 will be subtracted from the mean of X. The 89 will be subtracted by the mean of Y. And then those two values will be multiplied. And that will go for every item in this list. So let us go and see how it goes. So here is the X. We sum up and divide it by 10 to get the mean of X, which is 9.5. Then for each value in X, like 5 minus 9.5 equal minus 4.5, etc. You do it for every item. The same for the Y. Then the result, you will multiply them and you get the following result. Something to note here that 9 out of 10 of those results have positive value. Okay, so when we sum up those values, as you can see, we are getting a positive value, and big positive value means more that somehow there is a strong relationship between those two variables. But how can we judge it? We need to investigate it further. Now, since we are dealing with the sample, we have to divide it by the number of items we have minus 1. If we had the population, you will be dividing it by n only. So we went ahead and we calculated the covariance between X and Y, which is generated by this variable is called S and XY. And the value is equal to 40.61111. So that's good. So if I look at the plot one more time, so this is the same plot we have here, but what we did is we want to look more into the data. We know the mean of the X is 9.5, so let us draw a line a vertical line on the x mean and a horizontal line on the y, and try to analyze the values of those regions. You can come up with those four regions, and you can interpret it more by saying the following. Every time x goes up or increase, we notice that y increase as well. So take a look at this value, then this value, then this value, most of the cases. And the same in that region over here where we have the most points in this data. Every time x increase, y is increasing. So what we come up with from this, we say that there is a positive relationship between x and y, and that positive relationship is denoted because we say x is increase, y is increase. Now you might end up with different situations with different data sets where you can also see the trend. Like I can have a virtual line in this direction. However, as you can see, the x increase and the y decrease. So for example, this is the first point I have, or based on the x, this is the first point, the smallest point of x. So x is very small, y is very big. X is increasing, y is decreasing. Pick this dot. X is increasing, y is decreasing, and etc. So this type of relationship is called negative relationship. The third situation you can end up with is something called near zero situation of relationship, where there is no relationship at all between x and y. And we're gonna give you some rules of thumb how you can say this is a positive or this is a negative and this is no relation at all. So let me show you this rule of thumb. If you look at the values of, in general, of any values of correlation, it goes between -1 and 1. Always, always. There is no, if you calculated the correlation and the value is outside this range, that means you did something wrong. Okay? If it's between 0 and 0.4, negative, positive, there is almost no correlation. The higher it goes, the better correlation you have, the higher correlation you have. Okay, so this is a rule of thumb, easy to be understood. Okay, so after that, we can say the following. The covariance can be used to measure the strength of the linear relationship between two variables, x and y. Positive, when we have a positive value, one of them increase, the other one increase. Negative, when we have opposite relationship, one of them increase, the other one decrease. Okay, now the units of x and y might be different. We are lucky in this example that the units used here are similar. Like we said 5 by 10,000, 50,000, y, it's equal 890,000. So the units are closely related, but you can see the volume, how different it is. Like this one we are talking about from 0 to 100, where here we are talking about the value of the cells from 0 to thousands. So there is a power, one of them will affect the value more than the other. So to be able to standardize your value, if you remember the z-score, something similar here, we need to standardize to come up with a new measure that help us to overcome these differences in the magnitude between the two variables. To do that, we use a correlation, and all you have to do, you use exactly the same. You calculate the covariance that we did here, the SXY. You calculate it. However, you divide it by the standard deviation of x multiplied by standard deviation of y. In this way, you standardize the value. So R can be the one represent the actual relationship between x and y. For this specific example, we calculated the standard deviation for x, we calculated standard deviation of y, and then we use those two values in our calculation for R, the correlation coefficient. We pick the covariance, we divide it by those two values, and we come up with the correlation, which is equal 0.93. Almost 1, very, very high value of correlation. So remember the ruler again. So we are in this area between 0, 8, and 1. Very strong correlation, and it's positive. That's how you can summarize it. So a summary, correlation coefficient is the way that you can measure the strengths between one variable and another variable. The covariance, it indicates if we have positive or negative, but the magnitude depends on the unit of the measurement used in the data. So that's why we cannot really use it to indicate the strengths. We always use a correlation instead. Okay. The other aspect, which is we started this video with, how about having a virtual line that can really represent the relationship between x and y, and this is what is called the least squares line. We want the best fit line in our data, and there is a way to calculate it. All you need to calculate any line is the slope of the line and the intercept. The slope of the line is the division of the covariance that we just calculated over the variance of x, because we are trying to calculate the y based on the x, and here this is how we can do it. The b0, which is the intercept, very easy, is the mean. You take the mean of y, you subtract it by from the slope multiplied by the mean of x, and you get the intercept. And we did it for this specific example. We ended up with the y hat equal to 66.2122 plus 4.43 multiplied by x. What that tells us, now we have a line, and we can predict in future any value y in between these regions. Okay, from region 0 to etc. we can calculate it, we can predict how much the sales volume if we know the advertising expenditure. So one example here is, let's assume I have advertising expenditure equal to 10. I get the 10 multiplied by 4.4303, sum it to the intercept 66.2122. I will get the anticipated or the predicted value of y, which is in our case equal 110.5152. We have to remember this is going to be multiplied by 10,000. So actually we're going to have about 1,105,152 value for y. Okay, so we can say, because we have a very high correlation, that we might get very close to the real value. However, we never know if this is the real value or not. We are close enough. However, for the accuracy measurement, there are many different procedures you can use, and it's available in your chapter 13. We're not going to cover it in this course, but if you are interested in knowing how you can assess the accuracy and or the prediction of your y hat, there is plenty of information in your chapter 13. Okay, what to do next? Go ahead and look at the exercises in page 165 and 166. Try to work on them on your own without looking at the answers. I will provide the answers in your Blackboard, and try to compare your finding with the actual solutions I give you in Blackboard. So, and we'll see you in the next video.